Hello and welcome. How are you doing?
You know what? I'm really hungry for some math.
Oh, I'm not, because I at 1.8. So anyways, we're going to look at quadratic equations. We have looked at quadratic expressions, but an equation has an equal sign. That is the key feature. So you look at the difference between these two here. This one is a standard form quadratic expression. And then seeing the exact same thing with an equal sign and something on the other side of that equal sign is a quadratic equation. They're both quadratic because they have this power of 2 business going on. But that's the key difference between them. And we can solve quadratic equations. There's a number of ways to do so that you'll learn in future years. We're going to solve them by factoring. And we can always do that if the quadratic expression that's present in that equation is factorable. The rationale here is that the product of 0 and any other real number is always equal to 0. So, if any factor of an expression is equal to 0, then the value of the whole expression will be equal to 0.
Okay, so let's take a look here at this example. So we want to look at the quadratic expression x squared plus x minus 6. And now the first thing it says are what are the factors of that expression? So take some time right now, try and factor that. But when you do, you'll find that this quadratic expression is equal to x plus 3 times x minus 2. Now the question says what are the factors of this expression? Well, the factors are x plus 3, that's one factor, and x minus 2, that's the second factor. And of course, the order doesn't totally matter because it's a multiplication statement. Now, the first bit, or the next question here, I should say, says what is the value of x? What value of x would make the first factor equal to 0? So let's deem this our first factor here. Well, we want to know what x would be if this whole thing were equal to 0. So I'm just going to set it up as an equation equal to 0. And I'm going to solve for x. And to do that, I'm going to subtract 3 on both sides. And I get x is equal to negative 3. So if I plugged in x is equal to negative 3, I should get that first factor equal to 0. Now, the second bit says what is the value of the whole expression when x is equal to that value? And that whole expression is this guy here. So let's plug that in. Let's go, well, instead of x, I'm going to plug in negative 3. So negative 3 squared plus negative 3 minus 6. Of course, I'm making sure to put brackets around my negative 3 when I'm plugging that in, because otherwise I will not get the same response. Negative 3 squared, 9, minus 3, minus 6. Oh! That gives me 0. What a coinkadink. All right, now let's try it again. Next question says, what value of x will make the second factor equal 0? And here, in this case, I'm going to deem that my second factor. And let's try and find out. So let's set it equal to 0 and then solve for x, same as we did before. We isolate, and we get x is equal to 2. Now, what is the value of the whole expression? Well, that's again asking what's the value of this whole expression when x is equal to that value. So let's plug in 2 every single time we see an x. I tend to always put brackets around any value I'm plugging in just so I get into a good habit of not goofing with those signs there. And I also end up with 0. What a cool feature that is.
It is pretty cool, just like math, which is also cool.
The coolest.
Well, obviously, yeah, I mean, can you think of something cooler? Where's those cricket noises when you need them? So, we notice that both of these give us an answer of 0. Big donut, big donut. What's interesting, of course, is that those came from each of our factors, and as was mentioned earlier, was that if any factor of an expression is equal to 0, then the whole expression will be 0. And that's because when we plug in something like, oh, I don't know, negative 3, whoop, it goes into that x and it goes into that x, making this one a 0, making this one like -5, but 0 times -5 is just 0.
Ooh.
Yeah, that was pretty dope. And similarly, when we have x equaling 2, well, it'd go in there, it'd go in there. 2 plus 3 is 5. 2 minus 2 is 0. Once again, that product is 0. So what we get is a method to solve quadratic equations by factoring. Our process is going to involve each of these steps. So first of all, ensure all the terms are on the same side. In this case, oh, we don't have a case, huh? Just make sure that there's 0 on the other side. So if you've got something like x squared equals 7x minus 6, it's like, whoa, let's slow down. We need one of those sides to say 0. So we'll have to adjust that. Erase.
And we'll see that in our first example.
Is that the first example? Gracious. Crazy. We'll next have to factor. So once we have everything on one side, then we can factor. We can separate into two equations, because one will be with the first equation equaling 0, just as we had here, and one will be the second factor being equal to 0, as we had there. Finally, we'll solve each equation, and whatever we get in those two equations, both of those will be valid answers to our equation.
All right, so we're going to look through this first example here and just walk through it step by step. So we are trying to solve this. We're trying to, remember that solve is that action word, is looking for a value that x is equal to that makes this equation true. Okay? So, first step, we're going to move everything over to one side. So if we're looking at our equation here, notice it's an equation because there's that equal sign. We have most of our terms on the left-hand side, but we also have this constant on the right-hand side. We want one of those sides to equal 0, so we have to move that 10 over. So our first step in moving everything to one side and have 0 on the other is to subtract those 10s from both sides, which will give us 0. Now that we have, in this step here, all of our terms on one side and 0 on the other, we can now proceed to factor. And we can factor it any way that we feel comfortable, but we should get x plus 10 and x minus 3. From there, we've just accomplished 2 steps. The next step is to take each of these factors and set them into an equation equal to 0. So x plus 10 would then become x plus 10 is equal to 0, because we want to know the value of that of x that would make that first binomial or that first factor equal to 0. And we do same with the second. So we turn x minus 3 into x minus 3 is equal to 0, so we could solve for that value of x. Then we would proceed to do so. So when we're solving for this value of x, x would give us -10, and when we're solving for this value of x, x would give us +3. Both of those would be valid answers or valid solutions for x.
Feel free to give these next 6 examples a try. We will be going right into them. Of course, with this side already being equal to 0, we can jump straight to the factoring part. So you can give that a try, pause the video, do whatever you need to do. We're plowing ahead. I'm going to factor this thing. I'm going to say it's x minus 6 and x minus 2. And I do need to make sure that I keep that equals 0 in there.
A very common mistake that I've seen is that because so many people are used to putting an equal sign at the beginning, is they still throw that in there, but you can't have 2 equal signs in one line. That's a big no-no.
Yeah.
So if you already have an equation, which you do because there's an equal sign present, you don't need to add a second one in that same line.
Good point. That's an excellent point. Now from here, we've got our factored form. Our next step is to break this into 2 equations, where one equation is with the first factor being equal to 0, other equation is where the second factor is equal to 0. And we solve each one of those cases. Oh, yeah. Boop, out. X equals 6, or x equals 2.
Why do you say or and not and?
Well, x can't be two things at once. 6 and 2 are different numbers. If I said I had 6 apples and I have 2 apples, I mean, how many apples do I actually have? I gotta get it together. So 6 and 2 are different numbers. X could be either of them, but it can't be both at the same time.
All right, taking a look at this next example here, step 1, we're moving all of our terms to one side, and this 5 needs to get the boot. So subtracting 5 from both sides, here we are, we get x squared plus 3x minus 10 is equal to 0. Step 1, complete. Step 2, we are going to go ahead and factor. If you need a couple of minutes to go ahead and factor, please do so. But I'm going to keep on going here because you already know how to factor. You don't need to see me do it for you. We should end up with x plus 5 and x minus 2. Now those are the two things that multiply to give me 0. Well, what happens if this first one were to equal to 0? X plus 5 is equal to 0. And what would happen if the second one would give me or would equal 0? Right? We know that if either of these two things equaled 0, that yellow blob, 0 times x minus 2, would give me 0. Or vice versa, x plus 5 times 0 would still give me 0. That is why we're setting up these equations. All right. From here, we're now just solving for x in both scenarios. So I'm moving that constant over, and I get x is equal to negative 5, or x is equal to positive 2. And those are both my solutions for x.
Moving on to her. Whoops. What's the color? Sure. We've already got 0 on this side. I'm really lucking out with those ones. So all I have to do, kind of set it up that way. I stack the deck here. So I'm just going to factor. And of course I'm saying equals 0 over here, and I'm not saying equals 0 on that side. And then I'm going to do some stuff, which I think looks like that. And I'll break us into two cases. Maybe 2x plus 1 is equal to 0. Maybe x minus 5 is equal to 0. In this case, that means that 2x must be negative 1. And dividing both sides by 2 means that x is negative 1/2. On the other side, we're adding 5 to both sides. X is equal to 5. So it's either of those.
Keep in mind that when you're showing your work for this, you need to show all of the steps. You don't need to show the little intermediate work here as much. That's not as important. But the biggest thing is, let's look at this example over here, is that you're showing your first step of turning things into all of our expressions, or all of our terms on one side and 0 on the other. You need to show that. You need to show your factoring. You need to show these two equations equaling 0 to then logically flow into solving for x. You need to show all of that work in order to get full marks. Sometimes people find that it's easy to kind of jump from here to here. That is not sufficient. You will lose marks because it doesn't provide a logical flow of how you got from one point to the other.
And you might be able to see it, like a lot of us could see that from those factors, we'll get those answers, but we need to make sure we're establishing that connection between the whole quadratic equation and the ones that we break it up into.
Yeah, math is like a story. You can't just have the beginning and the end. You've got to get the middle in there too.
That's the juiciest part.
All right, moving on along. We do not have 0 on one side, so we have to move that 21 over. And so we get 6x squared plus 11x minus 21 is equal to 0. So now we're set. Take a moment to try and factor this on your own. Did you do it? You should be able to do it. And when you do, hopefully you got this. 6x minus 7 times x plus 3. Now, if one of those factors is equal to 0, the whole thing will equal to 0. So let's see if the first one will equal to 0. What should I get? Well, I will get, I'm working along down. I've added 7 to both sides. Now I have to divide both sides by 6. So I get x is equal to 7 over 6. Fractions are completely reasonable solutions. Sometimes we panic a little bit when we see a fraction, but fractions are friends. Whoop, whoop. So x is equal to 7/6 is one possible solution for x. What about with my other factor equaling 0? Well, I subtract 3 from both sides, so I get x is equal to -3. And of course, x can't be both of those values at once, so I say or, and I call it a day.
Hey, I was thinking like 7/6 is what, 1.17? Can I just write that?
It's best not to, because you're actually rounding your final answer there.
Oh.
Yeah, so we're going to try and leave things in fractions because it'll help us in our calculations. It's a lot easier to calculate down the road, but we're going to leave those as fractions as best as possible.
Yeah, okay. So I'll make sure I'll leave all my answers exact. I tried to pinch zoom here. That's as far as zoomed in as we can go. That's exciting. Oh my goodness, how am I going to factor this? It's a behemoth. No, hold up. I might have a perfect square trinomial. I'm just going to guess that I do and then check it later. 2 times 11 times 2 is 44. I'm in business. I wrote down correct things. I'm moving on. In this case, if you can still break up into two separate cases, but they're the same case, where one would say 2x minus 11 is equal to 0, and the other would say 2x minus 11 is equal to 0. That's the same thing. So we don't need both of those. We just straight up say 2x minus 11 is equal to 0. And then we can isolate. I'll add 11 to both sides. We will divide by 2. So in this case, it only had one possible answer. Why didn't box it? Thank you.
And we do not have to change any of this to mixed fractions. We could leave them as improper. Oh, hey, check this out. I finally got a 0 on one side. So I can go ahead and straight up factor as well. What I might notice is that all of those terms are divisible by 2. So what I'm going to do is I am going to pull out a 2 so that it'll make my factoring easier. So I end up with 2 times 6x squared minus 13x minus 28, and that's still equal to 0. Okay. Going ahead, I can now factor this. This is a little bit easier to factor because the numbers are a little bit smaller. And I end up with 3x plus 4 and 2x minus 7. Now, I'm still going to see, well, I have a multiplication statement between 3 things now. Right, between 2 and then this 3x plus 4 and this 2x minus 7. Okay. Well, 2 can never equal to 0. So I'm never going to deal with that GCF unless that GCF had a variable in it, okay? But it does not. So I'm only going to see and try and solve for x when my 3x plus 4 is equal to 0, and same when my 2x minus 7 is equal to 0. See what happens. Now for my 3x plus 4, I'm going to start by subtracting 4 from both sides. So I get 3x is equal to -4. Now I'm going to divide both sides by 3, so I get x is equal to -4/3. And for the second guy over here, I'm going to start by adding 7 to both sides, and then I'm going to divide by 2. So I get x is equal to 7/2. Of course, they're not the same, so I'm going to say or. I'm going to box my answer so it's incredibly clear. And yeah, I'm going to call it a day. Notice that there doesn't say at the bottom homework practice in the textbook because we've got you covered.
Woo!
So you will have some time to work on that. Give those a go. Otherwise, that's all for now.
Adios, muchachos.
TTFN. Ta-ta for now.